Thank you, Dr. Ryder, and everyone, even if you're all on the left side of the class here. I like your style. I couldn't be more delighted to be here. When I was invited to give a talk, I began immediately thinking about how to frame, I think, some intriguing questions, analytically very important, socially, yet to make the grade to interest the larger policymakers. How to do that in a way to elevate interest in this topic. Suffice to say, what we're going to talk about here today, none of the current candidates for President of the United States have any insight into this. And it will be a huge opportunity that every one of them will miss if we don't think about how to reframe energy for the 21st century. So in a lot of ways, what I really want to do is simply take a step back and offer a way to imagine a different way of looking at energy than we're normally used to doing. And to do that, we'll get this jump started here. Apologies, we have a bit of a... There we go. All right. So talking about what I refer to as the economic imperative. Not just a nice thing to do, but the imperative of dramatically increasing the energy efficiency within our social lives, within our economy. And to do that in a way that's very much in the spirit of Mary McLeod Bethune. I happened to get really interested in her life, so I took a step back to read about her in 1904. What she did, humanitarian, stateswoman, educator, a collaborator, the epitome of a collaborator in many ways, with 6 students, 5 young women, 5 girls, and her son Albert, with $1.50. Imagine to start a school with $1.50 in your purse, maybe $45 in today's currencies, and to do what she did. So this talk is very much in the spirit that she brought forward to Bethune-Cookman University, collaborative spirit, but also in the spirit of the tradition of Nobel laureate, former Caltech physicist Richard Feynman. He, in 1959, I encourage everyone to read this very engaging talk that he gave. There's plenty of room at the bottom. The reason I urge you to read the talk, yes, he's a Nobel laureate, a physicist, but there's not a single equation in there. There is not one person in this room who could not understand this very deep, this very profound talk. He was saying in 1959 that we have no sense of the opportunity ahead of us because we are so constrained by our thinking. He was saying in 1959 it was possible to store the entire Encyclopedia Britannica on the head of a pen. This was 30 years before Dan Eigler, IBM scientist, learned how, in 1989, to manipulate cesium atoms under a microscope to spell out the words IBM. He was imagining that there is more opportunity, more physical space for us to change the way we do things if only we will step back and ask questions. And I would add, in the spirit of Mary McLeod Bethune, to step back, ask questions in collaboration with each other, to interact, to learn, to teach, to ask better questions opportunity. Let me ask, let's be frank, how many of you are going to fact check me in real time today? All right, I have one. All right. Anybody else? All right, we're going to have somebody else. All right, this is good. Yeah, you see some old guy wearing a coat and a tie that doesn't really match. You think, how can somebody talk about this? He can't even dress reasonably well, right? So I'm going to make it easy. Do fact check me, because it's part of the conversation. So I'm going to make it even easier. I'm going to have the first, say, 3 rows fact check me on anything that you hear me say about energy. Or we're going to collaborate. The next 3 rows fact check me on anything I say about economics. And the back row over here, anything that I might have to say about politics, about social well-being, about community. So let's do, and let's bring it forward to engage in a conversation again. I hope we'll have enough time at the end to bring forward in the spirit not of trying to trip me up or find me wrong necessarily, but to engage in conversation. So in that same spirit, both Richard Feynman and Mary McLeod Bethune collaboratively changing the world and the questions we ask to see if there might be a better way forward. So in that spirit, I'm talking about a conversation Bethune-Cookman University, not necessarily just a presentation I have here today. So in that same way of being collaborative, I offer not so much a talk as a 5-step thought experiment to help us all understand this thing I call the economic imperative. And as we will see, the opportunity to do something about it. We're going to explore, in ways we've not done before, the critical difference between energy as a commodity, a kilowatt hour that we might buy in our electric bill, a gallon of gasoline. That's how we understand energy as a commodity, but rather energy as the ability to do work, to promote the social well-being, the ability of energy to transform matter into desired goods and services and distribute them in ways that make our lives better. The important difference of energy as work rather than commodity. And then we're going to examine the current magnitude of energy as waste, because waste actually constrains the robustness of our economy, and we will be in deep trouble if we do not figure out ways of turning that around. And then we'll review the link between energy efficiency, as Dr. Wright has already suggested, the link between energy efficiency and economic well-being, perhaps expressed in per capita, GDP, personal income, what have you. And then to examine emerging plans to transition the social economy. And notice I'm integrating both social and economics together, so we have to go hand in hand. Based on my colleague Jeremy Rifkin, some of you may have read his book. He wrote a bestseller in 2011 called The Third Industrial Revolution, and how we're using that idea to work in communities in Europe and elsewhere to make this possibility actually materialize. And then to offer a final thought and suggested next steps ahead. That's where we're going to go. And I hope that you're fact-checking and you have some good questions to engage in discourse at the end of the talk. Let me begin with two different perspectives on the U.S. economy. Let's begin first by talking about, not just talking, but talking about the sustainability elephant that's in the room. As an economy, we say, how can we provide jobs? How can we provide income to our communities? How can we have economic security? But we typically overlook and ignore or treat as if it's an afterthought or someplace away from our community or economy, the very big elephant in the room that is climate change. Huge impacts. In fact, February, we just saw a colleague of mine report in the Washington Post, February was 1.35 degrees centigrade warmer than ever been in history before. February alone. 2016 is likely to be the warmest year on record, the way it was trending already. And we're beginning to see an erosion of the ice shelves because of the warm water underneath the ice, not the atmosphere, but the warm water under the ice that could contribute to sea level rise more quickly than we thought. Climate change is a very big deal. Yes, but we also ignore that the same elephant in the room is delivering a very weakened economy, and we'll talk about that. And the irony is that both the inefficient use of resources, both are driven by the inefficient use of resources. Climate change, because we're wasting more in the way of energy and resources we put up in the atmosphere, and the inefficient use of resources creates costs that clamps down on our economy, weakening the prospect for future jobs, your future directly at stake. This is true whether we're talking materials, we're talking food, water, but especially energy. That's one view of the economy. We don't talk about this and bring it forward as a very active part of our life. But secondly, the economy depends on the way we look at the problem. So here we have a change in our economy measured by GDP on this axis over here over time, 1950 to current time, and what economists begin to look like after the year 2050, your future. We typically say, well, we've bounced up and down. We've gone from real good, we got real bad, real good, real bad, and say, if we just let business as usual track, we're going to go back up again. And so we go out a few more years, looking only at the short run, we'll go back out again. We'll look at another few years, up and down, say, let's look into the future. We'll go out again, let's look into the future. More to the future, without realizing that there has been a slow, steady erosion of our economic well-being And I'm suggesting this is by no means unique to the United States. In fact, you see this pattern in the developed countries, in the developing nations as well. Globally, this is beginning to happen. Different numbers, slightly different trajectories, but there is a slow, steady weakening of the overall well-being of the economy. And I'm also suggesting that a future robust economy will be eroded by the huge inefficient use of energy, other resources, their production and the consumption of those resources. If we value our future and the sustainability of our community and our economic well-being, we need big time to address these huge inefficiencies. So before we continue, I'm going to ask some questions, get a sense of the audience here so I know how perhaps to shape some of my thoughts. I want you to raise your hand if you know the name James Watt. You know he is the innovator behind the steam engine. Raise your hand. James Watt, steam engine. All right? Good. All right. Henry Ford, raise your hand if you know he is the innovator behind the assembly line production. All right, more hands going up. This is good. All right. Good. Good. Louis Pasteur. He was famous, if you know, raise your hand, for the pasteurization milk. That's where he gave his hand. He understood that bacteria in milk then had to be pasteurized to kill that bacteria to make it drinkable, right? You may not know this, but raise your hand if you believe there are over 200 years of coal to supply our economy. Okay, fewer hands, okay, all right. And then raise your hand if you know or you can believe that per kilogram of material, dynamite has more energy than, say, a hammer. All right, you think that's true? Now I'm going to ask you, how would you feel if every time somebody raised their hand, they were wrong? They were wrong.
Because somebody before those names had discovered this similar system?
I'm sorry?
Would it be because before someone that you have listed also had discovered that?
Oh, this man knows this stuff. All
The
right.
steam engine was very well known to ancient Greeks, for example.
Yes, but so let me take the step forward. Let's build on that exact idea. So James Watt, yes, he was the innovator behind what we now understand steam engine. There was Newcomen's engine before that. The Greeks had a steam engine. But the difference was James Watt did not bring it to market. Matthew Boulton, his business partner and investor, it took a collaboration. It was not James Watt, but actually Matthew Boulton, who made the steam engine part of our economy. Secondly, Henry Ford. Yes, Henry Ford did introduce machine and assembly line production, but his real innovation was understanding that in order to sell cars, you had to bring the costs down. And the way he decided that could be done was by instituting something that had been invented 10 years before. And it was a guy by the name of Michael Owen. You can check this out. Owens, Illinois is the company that now lasts. He produced a bottle assembly production technique for bottling beer, I'm happy to say, 10 years earlier. And it was that idea that Henry Ford recognized if he's going to bring the cost of the car down, he had to take advantage of assembly line production as represented by Michael Owen's automatic bottling machine. Louis Pasteur. Actually, his first work that brought him prominence in 1876 was not milk, but beer. He discovered germs that were contaminating and making beer tainted, and that's where he developed a pasteurization technique. Only later did he introduce that in milk. 200 years of coal. Actually, there's more than 200 years of coal, but the critical issue is only if we start to pay an increased cost to make that coal available. Yes, there's 200 years of supply, but not at today's prices. Prices are going to have to go up very high, and even then, things like climate may clamp down on that resource and no longer make it available. And finally, turns out there's more energy in hamburger than there is in dynamite. But it is dynamite that has the ability to release that energy more immediately, more forcefully. That makes us think it's more powerful than hamburgers. So all of these are ways of understanding our thinking. It's what psychologist Daniel Kahneman calls the availability bias. In other words, we're so used to thinking one way, information so immediately at hand, we automatically jump to a conclusion and make assumptions that may not be real. In a very similar way, I'm suggesting that the role of energy needs to be placed in that context. Understand it one way, yes, but let's take a look at it from perhaps a more critical point of view. So we begin with two views on energy, as I've already alluded. The typical view is energy as a commodity. That is to say, things we buy in the market, whether it's a barrel of oil, a ton of coal, kilowatt-hour of electricity, a cubic foot of natural gas, a commodity. These are things that can be easily tracked by statistical entities, government agencies, and the like. It's information we receive or made available, so we believe it's all there is to the story. I'm suggesting that more vital is energy as the capacity to do useful work. I've already suggested this. Work as the ability to transform matter. It takes energy to transform matter into the desired goods and services and make them available and distribute them as they might be required, as we think they might be required for our community or economy. So the end result and offering is that if we want to ensure the appropriate development of innovations that ensure the sustainable social and economic activity, the emphasis needs to be on understanding energy as work more than energy as commodity. Don't want to forget the one, but we absolutely need to understand the other in ways that we've not done previously. So let's explore this idea of energy as work a bit. Typically, when you and I talk about energy, we talk about a gallon of gasoline or a ton of coal, as I said. But what we are really talking about, and we don't know this because we're still unfamiliar, we're really talking about this thing we call exergy. Exergy is the high-quality energy that is available to do the work, to provide the heat, the electrolysis, to provide the thermal, the chemical reactions, the high-quality energy. And then there's not useful energy we call anergy. These are terms you don't hear very often, but they're important to understand. My colleague Bethune-Cookman, and he's a a German physicist, wrote a book called The Second Law of the Economy, 2011. And yes, energy is constant, but energy is constant because it consists of exergy, which is high-quality work that can be done. And once that work is done, the energy becomes degraded into anergy, and those two together comprise energy that is constant. That's an important idea. Now, my colleague Robert Ayers, his former student, PhD student, Benjamin Warr, in 2009, wrote a book. I've elaborated on that with two recent articles. I've said work, the amount of work we can do to transform matter, is this thing we call exergy, times the efficiency with which we convert that exergy into work, into goods, into services, into economic activity. And by definition, then, waste is basically the exergy we don't use, the one minus energy, efficiency rather. Important concepts, because if we start tracking energy as work, we begin to see a different kind of parallel or economic activity emerging. So energy equals constant, we think. The usual view is something like this. The total energy, and I've not drawn this to shape or scale, it doesn't matter, but we have the assumption that there's all this energy out there. And then we come along and we say, aha, but remember, energy equals exergy, the useful high-quality ability to do work, and energy, the useless stuff, two together equal energy, and it's constant. So now all of a sudden we draw a distinction. Here's all this energy, but here's the useless energy, and here's the high-quality exergy. Again, not drawn to scale, but to give you a sense of it. And as we use that high-quality energy up, we increase the waste. And as we're going to find, that waste creates costs. And what I'm suggesting is the high-quality exergy is used up, more and more waste, or this energy, but the total energy always remains constant. That's the second law, that's the laws of thermodynamics. I bring this out because then this allows us to understand the differences in reporting this information in ways that has not been very useful to economists or planners, what have you. So we're now going to compare what I call reported energy with applied exergy and useful work. Typically, the statistical agencies in the U.S., the Energy Information Administration may be the group part of the Department of Energy. And they may say all the tons of coal, all the kilowatt hours of electricity, all the barrels, tons of coal, barrels of oil, what have you, might look like this. Add up to that in any given year. And then we worry about the cost of it. But here is the actual work that's being done, the smaller signal. So we use all of this to get this. Except that this is an incomplete story because there is much more energy, high-quality exergy at work than we report. First of all, we report only this amount, and we report it as commodities, but there is this larger amount that's at play, and whether it gets converted to work or not creates that sense of waste. The difference between useful work that's completed and the total exergy consumed amounts to waste, or energy, as we've talked about. Why is that important? We're about to take a look. I gave a talk in Zurich 2 years ago, and I had two friends of mine who were quick sketch artists that heard me talking, and they drew this diagram. I thought it illustrates exactly the point I'm trying to raise. Funny how quick sketch artists can bring it home like economists very often can't. Here we have this little stick figure. We could call that our economy. And we're only 14% efficient in converting all that high-quality exergy into work. And we have this huge burden of waste. It is hard to be nimble. It is hard to be innovative. It is hard to be easily transitioned to a more productive use when we're burdened by this magnitude of waste, and we're only converting this into work. Very hard to be innovative at all when we're burdened by this kind of waste. One way to get around that, obviously, is to begin reducing the amount of waste. So here I've taken some data from the Energy Information Administration and elsewhere, and I've plotted for the U.S. what we call energy productivity. How many dollars of GDP do we get for 1 million British thermal units? 1 million BTU is about 8 gallons of gasoline, roughly, or about 300 kilowatt hours of electricity. That's each of those about 1 million BTUs. So in 1970, we got maybe 60-some dollars of economic activity for 1 million BTUs. Our per capita GDP, measured in real dollars, so we're discounting for inflation here, was just over $20,000 per person in the 1970s. And it grew over time. So by 1990 or so, we might have had $120 per million BTUs of energy used in our economy, and we're up to $40,000 of income. And today, we're up to just under $160 of economic well-being per million BTU, per 8 gallons of gasoline, or per 300 kilowatt hours. And we're just short of $50,000, about $45,000 per person on average. Now, this does not deal with inequities, or this does not deal with the distribution of income. This is just average income. But if we want to see the economy grow, or we want to see a bigger return on our investments, we absolutely have to think about increasing our energy productivity so that tomorrow we can imagine a more robust economy. Okay? So, stepping into the solutions, a colleague of mine, Dr. Jeff Luke, who wrote a very important book well before the internet took off, but he was quite prescient, Catalytic Leadership Strategies for an Interconnected World. He wrote this in 1998. And he said, individuals have a natural tendency to choose from what he called, his emphasis, an impoverished option bag. It's the same reference I made a minute ago about Danny Kahneman, the availability bias. If the idea comes to us very fast, it's there, we assume that's the solution. We overlook, as Jeff said, about 30% of the total number of possible options on simple problems. And on more complex problems, we miss maybe as much as 80% of the potential